Welcome back, guys. This is question 2.15 and the statement of this question is a variety of voltage source values were applied to the device shown in figure P2.15a. So this is the figure where this is the voltage source, this is the current, and device is connected with it in series. The power absorbed by the device for each of the voltage is recorded in table given in figure 2.15b. This is the table where the applied voltage is here and the power absorbed by this device is listed here as well. Use the values in the table to construct a circuit model for the device consisting of a single resistor from appendix H. So as it is known that this is a resistor, so here for the resistor the value of power absorbed by the resistor can be written in terms of the voltage is V squared divided by R. Okay, the only term here constant is this R. So therefore from this formula we can write the value of R is equal to V square divided by P. Okay, so all of these values, when for each of the pair here, this is pair 1 2 3 4 5 6, each of the row here will give us the constant value, and that constant value will be what, let me write it here. So that would be the R, and here it would be P, V square divided by P. So V square minus 8 whole square divided by 640 into 10 as power minus 3 for the first couple here. For the second one it would be minus 4 whole square divided by 160 into 10 as power minus 3. Why minus 3? Because this is in milliwatts. Okay, also for this one it would be 4 square divided by 160 into 10 as power minus 3. For the fifth one it would be the 8 square divided by the 640 into 10 as power minus 3, which is also equal to this 12 square divided by 1440 into 10 as power minus 3, and so on. Okay, the last one here will also be here, and that would be 16 square divided by 2560 into 10 power minus 3. So now picking any one of these values we can find out the value of the resistor. So let me pick this one because it seems easier. So to find out the value of the resistor from it, 4 is 16 divided by the 160 multiplied by 10 power minus 3. It would be this 16 is 10 times this, and it would be 1 over 10 to the power minus 2. Okay, or this is also 10 to the power 2 or 100 ohm. Okay, so that is the value of this resistor which is here, and this circuit can also be drawn like this one. This is the circuit, this is the voltage, and the resistor here is 100 ohm. Okay, so this is the solution of question 2.15. Let me proceed to question 2.16 because that is also the relevant one, and that is here. Okay, so in this question a variety of current source values were applied to the device shown in figure P2.16a. Okay, this is the circuit in which the voltage source is now replaced with this current source. The power absorbed by the device for each value of the current is recorded in the table which is here. The current is applied and the power absorbed by this device is here. Use the values in the table to construct a circuit model for the device consisting of a single resistor. Again, this is a single resistor, and this device can also be drawn like this one as we had previously seen, but this one is the current source. Okay, and the current source basically develops this voltage. Okay, this is the resistor as it is given, and we want to find out the value of this resistor. Okay, to find it out, again we know the power formula for the resistor, and that is in terms of the voltage which we previously seen was V square divided by R, while for the current that is P equal to I square R. Okay, so that is the value for it. In order to find the value of R from it, this formula, so it will be P divided by I square. Okay, so that is the formula in which the only thing here in this table which will remain constant will be this R. So let me formulate it for this one. So here this R is equal to what? P divided by I square. So P is for the first pair, here is for this pair, it would be 8.25 divided by 0.5, that is equal to 33.00 divided by 1.0 for the second one. Okay, for the third one, that is also the squarish. Okay, so this is also square. Also for the others it will be 74.25 divided by 1.5 square. Okay, and so on for the others one as well. Okay, for this we have to put it in this formula. Okay, so let us take any one of them. So let me take this one because it seems easier because of this denominator term, which is 1. So from it we can very easily see that the value of resistor is what? That is 33 ohm. Okay, and that is what? That is the value of this resistor, which is 33 ohm. You also need to keep in your mind that these denominator terms are the squarish ones. So therefore the 10 to power minus 3, this is 10 to power minus 3 will be here, and also in the squarish terms it will be 10 to power minus 3, and then it will be whole square. Okay, you need to keep in your mind all of these. You have to multiply the 10 to power minus 3 and then squarish term, because these cannot be cancelled out. One 10 to power minus 3 will be cancelled out while the other one remain the same. So therefore the answer here we would get would not be 33, but it will be, let me solve it here. Most of the people make this mistake, so therefore I have first gone through it and now I am solving it like it is. So it will be 33 into 10 to the power minus 3 divided by the 1 into 10 to the power minus 6 because of this squarish term. So it will be what? It will be 33 divided by the 10 to the power minus 3, which is 33 into 10 to the power 3, and ultimately we will get 33 kilo ohm. Okay, so you need to keep in your mind that this is not 33 ohm. Okay, let me do it. It is not 33 ohm, while this one is the 33 kilo ohm because of the terms here. Okay, you need to keep them here because most of the people, and I have seen it in many question papers, answer sheets, in many quizzes, that people cancel them out, and the remaining term here, which is the denominator, is in the squarish form, so they forget to put them here. Okay, so that's why I have solved it here separately. So that's it for today. If you have any question, you can ask me in the comment box. See you soon.